So let us start with the easiest problem first, and then we can. My plan for this session is to also cover some easy topics, which you might already know, but we can solve some problems just to make sure. And let's start with the first problem. Problem is just this. We are given an array of size n, and all we want to do is this. AIs are up to 10 to the 18 from 1, and we just want to reorder this array, and we need to determine if this condition can be met. For any I mean, there should exist some I such that this can happen. The minimum over here is equal to the GCD of this part. Like the minimum of a prefix is equal to the GCD of the suffix. So maybe it is a bit still hard to understand. So we can look at a test case. And all we need to output is yes or no. Whether can we reorder this array so that this can be met or not. So for example, if our array is 4, 5, 6, 9, 3, then we can reorder this array something like 3, 5, 4. Actually, we can just put the sorted order, I think 3, 4, 5, 6, 9. Now, the minimum of this part is 3, and the GCD of this part is also 3. So this is equal. So the answer for this will be yes, that we can actually reorder this array so that this condition can be met. So is the problem statement clear? Put a plus in the chat or yes or no. Let me know if you have any ideas. Just uh, just send me a message privately, not to everyone. So let me just give you some hints maybe, because we should solve this problem. Uh, I mean, the duration of this session is less as well, so we should keep our pace fast as well. So this part is minimum, right? And this part is GCD. So you can just observe what do these properties actually do. So this is minimum, right? So I mean, uh, this is the first observation is based on the actual minimum of the array. So if the minimum of the array is in this part, so what will happen? This value will be greater than this. Why? Because GCD of some numbers will be less than the minimum of those numbers, right? Less than equal to. Why? Because of course GCD is the common divisor of these numbers. So it will divide all of these numbers. So it has to divide the minimum number of which appears here, right? So if we have to divide that number, GCD must be less than equal to that number. Thus, it will be less than the minimum of all of these numbers, right? So if the minimum appears here instead of appearing here, like if there are more appearances, then we are saying all of these are appearing here. So all of those cannot appear here. Why? Because then the GCD will be less than the minimum of this part, but we want to make them equal. Thus, we can just say, like the first observation is just this, that the minimum must appear, let's say in the beginning, because we really want to have uh, we have we want to have a split point such that the minimum is equal to the GCD. So what else can you say? So you figured out that the minimum will actually remain the actual minimum, because if we just place it in the beginning, then it is remaining uh, the minimum of the array. So you know what will be the value of this part. Now you want to have the GCD of some numbers equal to the minimum. How can you do this? And is everything clear? Like, is this observation that if the minimum is in the other part, then it is never possible, because the minimum of this part will be greater than the GCD. Is everything clear? And if you have any questions, tell me. Basically, what I'm saying is the problem was this, right? We need to find the any any I or any split point such that the minimum of the left part is equal to the GCD of the right part, right? So all I'm saying is you should just analyze these properties. What is GCD and what is the minimum? Minimum is just the minimum of all of these numbers, right? And the GCD is the common divisor, the greatest common divisor. One fact which you can say about the GCD is, if you take the GCD of some numbers, let's say, I don't know, 4, 6, then it is always less than equal to the minimum of the elements which you have taken the GCD of, which in this case is just 4 and GCD is actually 2. So of course, GCD needs to divide every number uh, which you have taken GCD of, right? So if we are taking the GCD of this part, GCD has to divide every number. And to divide every number, it must be less than equal to that number. So we can just say the GCD of this part is less than equal to the minimum of this part, right? because it needs to divide every number. And so we said if it is less than equal to the minimum of this part, if we actually place the minimum over here, the actual minimum of the array, which is like the minimum value in the array overall, if we place it in the right part, then it is never possible to satisfy our actual condition, to which is to satisfy the minimum of this part is equal to the GCD of this part. Why? Because if you put the minimum over here, GCD will be less than equal to the minimum, and this part is greater than the minimum because we have placed the minimum over here instead of here. So this is greater than the minimum, the overall minimum of the array. Let's call it M value. And the minimum of this part is actually will be M. And GCD will be less than M. Even if it is M, it is still less than this part. So it will never be equal. We want to make them equal. That is why I can say that minimum must appear on the first value, because you can, I mean, say the same thing for the first split point as well. So if you want to actually satisfy this condition fast, or try to like make it happen sooner, then it is better to place the minimum in the first position. And by placing the minimum in the first position, you just have simplified your problem. You can say for any split point, you just want to know the minimum of this part is now always equal to M, which is the minimum of the whole array. And you want to equalize it to GCD of some numbers. You just want to put some numbers over here whose GCD is just M. It is better if you type, because if you say the solution to everyone, then it will not be good. For the rest, we can just say like what numbers help us in creating the GCD equal to M, and what numbers do not help us. Let's just think about that. So I can say if I am creating some part and GCD of this should be equal to the minimum value, what should I do? I can just place every number which can help me in this, which can help me in creating the GCD equal to M in this part, right? And which numbers help me? The numbers which are multiples of this value. Because if I take the GCD of all of those, then it must be M If it is not, then it is not possible, because all other numbers are actually making the GCD worse. I mean, if I add any number which is not a multiple of m, then it will destroy the GCD. I mean, it will give a factor which is less. And then, I mean, this is just a theory part, but if you have any number which is not a multiple of m, then the GCD can never be m, right? If you will think about it, you can understand it. But if you want me to go in detail, I can give the detail as well. It will be using prime factors and prime factorization of each number. So, but probably, I mean, you understand the fact that if you take the GCD of all of the numbers which are multiples of m, if the GCD of those numbers is m, then only then we can satisfy the condition. GCD should be equal to the m, right? So we will just put all of the multiples of m in this part and put all of the which are like the numbers which are not the multiples of m, we will just put them here. They will not reduce the minimum, of course, because minimum stays the same, and they are not the part of GCD, and they will like don't affect us, and the numbers which are helping us and they can help us. I mean, we have just put them here so that we can actually have a split point. So this is all. So all we need to do is, yes, that is right. And all we need to do is, I mean, just to check if the GCD of all of the numbers which are multiples of m is equal to m or not. But of course, we need to keep one m aside. I mean, we need to keep one m to the left side. If there is another m, of course, the answer will be yes, because we can just keep it in the right half. So yes. But and if you would like me to implement or show the implementation of anything at any point, you can just tell me. I mean, if you think it will be hard for you to implement, or you don't really get the whole idea. So do you understand the solution? Like how like each observation is working and how is the complete solution working? Put a plus or a minus the chat. So if you do not understand, just put a minus. If you do, then put a plus. What does nothing means? Yes, you may open your mic if you want to.
First, Assalamu alaikum, good morning.
Good morning.
I think I have a solution for this problem.
Okay.
First, we can make two vectors. One we call it GCD, and the other we call it min. Okay. Then we coming from the first elements in the vector A, and going ahead, elements by elements, and in every I of the AI of this vector, we put the min elements of the AI of the vectors from the first into the AI. We put the minimize in the new vectors we made mni. So the vector min will put the min من the lowest number in the vector from the first into the I. This is the first vectors, and the other vectors GCD we coming from the end and put GCD of every elements from the end until the I, and I is going from the end into the zero, the first the start of the vectors. Then the other loop, when going from the first in the I from the zero into the end, we check I if GCD I plus 1 equal min I, so it's yes, and we stop. Otherwise, we complete. And if
So
we going
you can you stop? Wait. You are not like considering the reordering as well. I mean, you can reorder the array. So if you are just answering for the brute force solution and which is wrong, I mean, you can reorder the array as well. So if you will just do that, it will not work. So, and for the next time, I think we should just use chat because otherwise it wastes some time as well. Because if I just, if everyone is just listening to one solution, then it is wasting other people's time, which are, I mean, not mine and not yours, but the ones who are also thinking on the problem but cannot think anymore because you are speaking. So let us just move to the next problem. Next problem is, let me also send the problem in the chat for those who may leave or I mean who may have some internet connection problems. So the problem says we have an array and we just want to a subarray is good if the sum of the elements is equal to the length. And that is all. So we just need to count the number of good subarrays. For example, I mean, let me actually explain it. Okay. So for example, the if the array is 1, 2, and 0, or let's make it a big, let's take a bigger one. Then we want to see how many subarrays have uh, the sum equal to the length, right? So of course, if there is a 1 in the if you just put one element, so it will be equal to the length, and if it is 1, right? So these 4 subarrays, and what else? This subarray and this subarray, which have the sum equal to 2 and length equal to 2 as well. So this will be the answer for will be 6. 4 are length 1 subarrays and 2 are length 2 subarrays. So all we need to do is count the number of LR or count the number of subarrays such that this condition is satisfied. Sum of the subarray is equal to the length of the subarray. So length will of course be R minus L plus 1. So how will you do this problem? First of all, let me just ask, do you know prefix sum? What is prefix sum? If you know what is prefix sum, put a plus, otherwise just put a minus. And I mean, putting a plus and minus should not take this much time. I mean, I want you to be very responsive. I mean, this is taking a lot of time if you just do not respond. So are you guys even listening, or I mean, what is going on? What is uh like doing, like not sending anything? So what I am asking is, do you guys know what is prefix sum or not? If you guys do not know what is prefix sum, just put a minus in the chat like this. Or a plus like this. So I just want you to think on prefix sums and see how can it be used to solve the problem. So what can you do here is just this. What is sum of LR? First, what is sum of LR? Sum of LR is just prefix of R minus prefix of L minus 1, right? This is how you get the sum using prefix sums. And that is just R minus L plus 1. And you can just see from here that this is just PR minus R is equal to PL minus 1 minus L plus 1. So now we have like the terms, but there is actually a better idea which is said by one of you, which is actually very good. But you can solve the problem in this way as well. This is like now that both of the variables are at like on the other sides. So we can just work with these. We just want, if we are at some R, we can just say PR minus R should be equal to what? Should be equal to this, right? So we just need to find the number of L points, like the number of points which have this, like their equation is like this, or their value when the L is this, it is equal to this, right? Because we need this value to be equal to this value, we can just say we know this value right now because we are at this point. You can say this is I or this is R. All you need to do is to count the number of L's which have their this value equal to this value. Of course, right now you already know this value, so you can just say how many values in your map or whatever you have stored are equal to this. That is all you need to do. I mean, you can have a map of count when you are at some L, or whenever you leave some R, you can just say this. You can just say P of I, let's say P of I minus I plus 1. This count increases by 1. And then when you are at some R, I mean, in the beginning, what do you do is just this. You just say answer plus equal to count of Pi minus I, because this is PR minus R, the current value for the prefix. And then you can just get the value of get the number of L's which have this value. This is all we need to do. So do you understand the solution? I mean, this was just prefix sum and just modeling the equation so that it becomes very elegant or clean. Like all the variables which are same are on the opposite side. And then we can, since we need to find the number of L's which will be equal to this value, like this value equal to this value. So all we need to do is to keep count at every L of this value, which is Pi minus I plus 1. And when we are at some R, we just need to see how many values are equal to Pi minus I. So this is the solution, and maybe this was a bit hard for you because you have not seen such a problem before, but this is a very easy problem of a prefix sum. And I just want to maybe increase the pace because I was told to do so, because uh, your feedback was also like this, that you want to increase the pace, you want to learn topics faster, and that is actually good uh, because you really have very little time, so we should increase the pace. So let me just repeat. let me actually use your idea because it is better than even my solution. So our equation is just this, right? Sum of LR is equal to the length. So what we can do is we can say sum of LR minus length is equal to 0, right? And what is length? Length is just the number of elements which are from L to R, right? So one of you gave a very good idea that we can just subtract 1 from each element. At each element, just subtract 1. What will this do? What will this do is whenever we will take the sum of a subarray, no, an empty array or an empty subarray is not good. Actually, let me reply in the chat. Let me actually even see the question, because even if it is, then it will just count once. No. Okay. So what does this idea do is just this. When you have subtracted 1 from each element, then you can say whenever you take the sum of this subarray, it is actually the actual sum minus length, because what you have done is subtracted 1 from each element. So how overall how much is subtracted? Overall the length is subtracted, because for each element you have subtracted 1. So overall subtraction is the length, right? So all we would need to do now is just this. When you take the sum of the new subarray after subtracting ones, let's say you have made the new array after subtracting 1 from each element, then you can have a prefix sum on this, or you can just create like this as well. So when you will have the prefix sum on the new array, let's say this is the prefix sum, then what do you want? You just want the sum to be 0, the sum of the subarray, because the new sum, just say the new sum is actually this value, the actual sum minus the length, and we want the that value to be equal to 0, right? As our equation says. So we will just do this. We just want PR minus PL minus 1 equal to 0, because this is the sum of the subarray from L to R, and we want it to be equal to 0. How can we do this? We can first change the equation to this, and do the same thing. It is very similar to my solution, but a little bit cleaner. So what will you say? You just need, when you are at some R, you see this value which is PR, P of R. You just need to count the number of L's which have this value, like the number of, let's say, L minus ones, for which the value is equal to this, right? So that when you subtract this, the sum becomes 0, and so that the equation is satisfied, right? So all you need to count is the number of values which are same before this value. How do you do this? You do this with a, let's say, a map, like using like let me actually go to the new page. Using, let's say, count, you will just say P of I plus plus. When you see this value, you just add it. Let me actually do this afterwards, because this will be used later. When you are at some I, you will first count the number of values before it which are equal to it. What is that value? It will be just, it is stored in our count. What does count give us? Actually, count gives us the number of values which are equal to this value and have appeared before it, right? And when we are like going to the next I or going to I plus 1, we can just say this is now also appearing, right? For all of these values, now this will be considered a possible L minus 1 as well. So do you understand the solution now? I mean, this is a good solution and a bit simpler as well. So do you get the solution? Do you understand it? Put a plus or a minus in the chat. Okay, so the last part, you mean how to use the map and how are we using it to get the answer, right? Let me repeat that part. Let me think on how should I repeat it. Okay. So actually our problem is just this. Forget about what we had. So forget about the actual problem. Let's just work on this problem. All you need to do, let's say we are given an array. Uh, put some. So what do you need to do is just this. You need to count the number of elements before it which are equal to it for every element. Like for this value, you will say 0 because there is no value before it which is equal to 1. And so will you say 0 for this, 0 for this, 1 for this. Why? Because there is a 1 before appearing before this value. What about 5? 5 does not appear before this 5. 4 does not appear before this 4. 3 is appearing once. 2 is appearing once. 4 is appearing once. 1 appears twice. 6 appears 0 times. 6 appears once. 1. So all you need to do is to find this array. How will you do this problem? Like how will you solve just this problem? That you have this array and you want to tell the number of values which are equal to it and appearing before it. So let me actually tell the solution because it's getting a bit late. So all we will do is just this. We will keep track of the appearances or the frequency, whatever the word you use. I usually use the count, but let's use frequency. Maybe you are more familiar with it. So frequency or count, whatever it is like how many times does this number appear? Like the number of occurrences of that number. So when we are here, we will just say frequency of 1, which is, let's say, of 0 or whatever the element is. So we will just increase it by 1. We will keep doing this. When we will reach here, we will just use, like, we will just say what is frequency of 1 when you came here. That will be the answer of I, right? And when you are passing from here, you will of course do frequency of 1 plus plus, because now it is also appearing once more. So for the next value, which is like here, so that the answer can become 2. Now, do you understand the solution for this part? That if we have to count the number of elements which are equal to it and appearing before it, we can just do it with a simple map or a simple count array. The elements are there. So yes, if you understand the solution to this part, our actual problem is now just this. I mean, what we did after doing this is like just having the actual sum. Like instead of this, now our equation became sum of LR equal to 0. And what is this? This is just PR minus PL minus 1 equal to 0. And we can model this as PR is equal to PL minus 1. Now what does this say? Is just this. How many elements are like for PR, it is just saying this. How many elements are equal to it and before it? How many elements before it are equal to it? So this is what we just solved. And that is what we are doing using this map for frequency array or counter. So it was a good problem since we were able to discuss some good concepts. Now let's move to the next problem. This problem is a bit, statement is a bit long. I will just explain it myself, or maybe I can send you the link as well. Okay. So basically, there is a monster, and what we have is there is a monster with health H, and we want to kill it. Okay. And how do we kill it? We will do some attacks, and health is up to 10 to the 18. We will do n attacks on it. And when do we do an attack? We do it on the AIth second. Like we are given the times on which we attacked the monster. Now, what do we want to say is this? We want to kill the monster with the let's say least expensive weapon. So we want to minimize the cost of a weapon. And what is a weapon? Like what does a weapon do actually? The more the cost, let's say if the cost is K, then what does it do? It does a poisoning effect on the, whenever it attacks, it will do a poisoning effect. So if you attack on, let me actually use their example because this is a really complex problem. So if we are attacking at times 2, 4, and 10, then, and if K is 4, what does this mean? This means we will attack we will attack on these times, but what will our weapon do is it will decrease the health of the uh, monster by 1 at these times. On 2, at time 2 it will decrease, at time 3 it will decrease, at time 4 it will decrease, at time 5 it will decrease. Why? Because k is 4, so it will last for k seconds. That is the power of a weapon. Like if the power of a weapon is k, the cost is k as well, and we want to minimize this cost, but we want to kill the monster too. And what happens at time 4? Time 4, it happens the same thing like 4, 5, 6, 7. But if there is an overlapping, this will not do -2. It will still do -1. So overlapping does not count. But it will do a damage on 6 and 7, and then it will do a damage on 10, 11, 12, and 13. This last 4 seconds, this last 4 seconds, this last 2 seconds, we got 4 and 5 were overlapping. And so let me actually use a test case as well. So let's say 2, 5, and 1, 5. So if the health of the monster is 5 and we are attacking on these 2 times, what is the minimum K which we can use to kill the monster? It is 3. Why? Because if we use, let's say, 2, then we will attack on all of these times. I mean, we will decrease its health on all of uh, these times, right? But this is just 4, like a decrease of 4. But we want to kill it, so we will need more than that. So if we do it using k equal to 3, then it will last 3 seconds here and it will last 3 seconds here, and this means a damage of 6, and which is greater than equal to the health, and it will be killed this way. So the answer will be 3. The minimum k which can be used to kill the monster is 3. Similarly, let's do another example maybe. Yes. So 3, 10, and 2, 4, 10, which were the actual previous times. The answer for this is 10. Wait, sorry. The answer for this is 4. As we saw, if we do 4, the times it will subtract will be 2, 3, 4, 5, 6, 7. Will it subtract on 7 as well? 4, 5, 6, 7. Yes. And then 10, 11, 12, and 13. So 4 times here and 6 times here. So overall damage will be 10. So we have killed the monster because its health was 10. So do you understand the problem? We have a monster, we want to kill it. There are times on which we attack the monster, and the weapon's strength determines how many seconds the effect will last, the -1 effect, let's say. So, and we want to minimize the weapon's strength because it is, let's say, correlation with the cost. So we want to minimize the strength of the weapon, and we just want to kill the monster with health edge. If the problem is clear, just think on the problem, and if you have any ideas, just let me know. If you do not understand the question, you can just tell me to repeat. let's start the discussion on this problem. So what we can do is binary search. Do you know what is binary search? If somebody does not, he can just put a minus, otherwise put a plus. I think I will just explain because you guys take a lot of time answering. So let me actually tell you a very good way of thinking on what is binary search. Well, of course, you have heard of the very classic problem, right? If an array is sorted, if an array is like in this order, ascending order, and you need to find an element, how will you do it? You will just do a binary search, right? You will just say whether this element x or the a of mid, let's say the value which you want to find is target. So a of mid is, if a of mid is less than target, then you know that target must be in the right half or in the half greater than mid. So you can say left is mid because now you don't care about all of these elements. First, left was this, right was this, or let's say this is low and this is high. This is the low pointer and this is the high pointer. So what we can do is this. We can just check if a of mid is less than target, then we can set L is equal to mid. And similarly, in the other case, we can just set R is equal to mid. Now I say that we can use this, we can actually do this for the reverse array as well, right? If the array is actually reversed and it is in the descending order, then you can do the same thing, but maybe you will have some other conditions, right? Actually, you can do the same thing. You can just say if a of mid is less than target, let's say this is L, this is R, or yes, for now, let's say this is L and R. So if a of mid is less than target, what will you do if this value is less than the target? That means target is greater, so target must be in this half, right? So the only thing which changes is R is equal to mid over here, and otherwise L is equal to mid. So let me actually generalize this. I say that we can always, we can always do binary search on something which is ascending or descending, decreasing or increasing, and there is actually a even more generalized way of saying this. So what property are we using here? It is just whether P of A of mid is less than the target or not. And this is like a Boolean. This gives us, uh, this is a function, let's say, and it is returning 1 or 0, right? So if we just check for every element or every mid, we will get a, if we just output this value, what is A of mid less than target, if the array is sorted in increasing order, then we know that it will look something like this. For this element, it will just say this is less than the target. So it will say yes, 1. This condition is satisfied. For this one as well, for this one as well. Let's say this is target itself. So this will say 0 because this condition is no longer satisfied, and so on. So this is how the form of binary search looks like. There is some property P, and it just satisfies for some half, and it does not satisfy for the other half. And all we care about is finding these 2 points. The points where, like, we only need to find 1 point, but we are keeping track of both. So what do we actually do is just this. We say L must be on a point which is 1, and R must be on a point which is 0. And if we just find these 2 points, we will know everything, right? Because we know that our string, this binary string, will look like 1 1 1 1 1, and as soon as the first 0 starts to appear, like as soon as a 0 appears, everything will be 0 after it. So that is why we can say we only need to find the first position of the 0 or the last position of a 1, and the whole binary string will be identified, right? So that is why, I mean, this is just theory, but you need to know this to solve many problems of binary search. So what we will do is just this. We need to keep L on something which is for sure 1. So we can, if our target is always greater than equal to 0, we can say, let's assume there is a 0 over here in the beginning of the array, and let's assume this is over L right now. And target is always, let's say, less than, wait, yes, target is, let's say, always less than infinity. Infinity can be something like 1e9 or 1e18, depending on the problem. This is just 10 power 18 or 10 power 9. And then you can put R over there. And that means this condition is never satisfied for this value, right? And we will just keep moving these 2 pointers closer until they come on these 2 positions. And when they come on these 2 positions, everything will be done. Okay, so this is a bit of a theory on the binary search. You can read more about this on the edu section of the code forces. Like, let me actually send you the link right now. I'm not sure if you will actually go there yourself. So you can read like step 1 and step 2 theories, but it is the step 2 theory which I am talking about. So this is the link, and it's in English, but you may use a translator. Yes. So how can we use binary search in our problem? Our problem is just how, first let's understand how can we even use binary search there. So what we said was, let's say there are some times, let's draw the times on the number line. Let's say at this time, at this time, and at this time, I am attacking the monster. And if my k is big, let's say k is something like this. So these are the times I am attacking the monster. Of course, if there is an overlap, this is just like I am actually starting from there. So what we can say here is, one thing which we can say is this. If our attack strength is 0, it will never work. The monster can never be killed, right? But if it is something like infinity or 1e9, actually h is up to 10 power 18, so it needs to be 10 power 18. 10 power 18. So if my if my weapon's strength is 10 power 18, then I can say that I can always kill the monster, right? Because at least I will attack 10 power at 10 power 18 seconds, it will get attacked and its health will go in negative, or let's say it will become non-positive. So yes, that's not an issue. This is the problem we are discussing. And I am talking about binary search. Which you can read more about this there. I mean, if you have missed some part of it. And I'm actually repeating anyway. So what we are doing is, like, since we are attacking the monster at these points, if we attack the monster with the strength which is very large, the monster will always be killed, right? Let me actually send the links again. Okay, so you can discuss later what we were talking about, but let me just continue, or you can see the recording as well. So all I'm saying is this: if we like uh, attack with a very large strength, then we can always like kill the monster. But if we do it with a small strength, we can never do it. But as soon as there comes a K that we can do it, we can also do it with K plus 1, right? We can also kill the monster with K plus 1 strength, if we can kill the monster with K strength, and so on. But if we cannot kill with K minus 1, we cannot kill it with K minus 2, and so on. So this is just like I cannot kill it, I cannot kill it, I cannot kill it till K minus 1. And when K comes, it says, yes, I can kill it, yes, I can, and so on. So this is how the general binary search looks like. Like whether we can kill it or we cannot kill it, this is our metric right now, and we will just do binary search on this. Our low can be 0 and our high can be 10 power 18. And then we can just say, let me actually show you the implementation. Okay. We just use the template so that we can implement it faster. So there is the number of health, I mean, the number of attacks and health. You take that input. After that, there are the times on which we attack. And then all we need to do is binary search. So how does the binary search look like? It will be like this. I'm not doing long right now. I will do it like later. So all I say is like till when they are at least one distance apart, because that is how I implement binary search. That at the end, low will be this and high will be this. And right now they are surely on a 0. I mean, they are surely on the determined points. So when I get mid, low plus high is 0, low plus high divided by 2. When I get mid, what do I check? So yeah, I did not explain. Yes, I will make it long now. So I did not explain yet how can we determine if we can kill the monster or not. So if we are attacking at these points, we can just say if our, like, what is our mid? Mid is like what we are trying to kill it by, like our current try value for K or the actual answer. So we check if we like have this k, let's call it k because this is what it is called in the problem statement. So if the distance between these two is less than k, then we can always use like our damage will be k. But if it is like 2, 4, and 10, as in the example, then for this two, it is like we are just attacking till 4, which is just attacking 2 points, 2 and 3, and then 4 attacks the next four elements, right? If k is 4. So we will just do this. We will say what is the damage we are doing. So damage is 0 right now, and you can also add some more elements for your own convenience. Like I can just add a of n is equal to 1e18 or 2e18, let's say. So what I can do now is just this. I can say damage plus equal to minimum of mid or a of I plus 1 minus a of I. Because as I said, either I can damage till the next point, but not including it. That is why I have not added plus 1. And but if they are close, I mean, if they are close, I can only go till there. But if they are not close, then I can use the whole k value. Like my damage will be for k seconds, which is right now our mid value. And when it's at the end, of course, it will damage for k. But when I will do this, a of n is 2e18, so it will always take the minimum with mid, which will always be mid. So my value will be correct. So actually, this will also exceed the limits because I need to make sure that it stays in the. So if n is like 100 and my damage, I mean, if my mid is like around 10 power 18, then I am adding around, like my damage value can become 10 power 18 times n, right? So this is why I can actually, no, not really. It will never be exceed 2e18. So it does not really matter. I can have this. So I was just thinking whether my damage variable can exceed even long, like can it exceed 2 power 64 or not? But it cannot. You just have to see this, and if something like this happens, I remember some problems that in which this can exceed. So you can just say if damage is greater than 1e18, just break here because we do not care anymore because we will be sure that we will be able to kill the monster with this damage. So yes, I can just do this, and then if damage is if my damage value is greater than the health, then I can kill it. So I will place my high variable, which always indicates that I can kill it. Like it always stays at a position that I can kill it with this value. That is the definition of my high variable. And this is a very clean way to implement the binary search, in my opinion. People have their preferences, but this way I do not have any plus ones or minus ones. And this is also quite clear that while the distance is greater than 1, while they are like apart and not close like this, if like this is our purpose, we want to bring them adjacent. And so this will be the like complete solution. At the end, our answer will just be high because that is the minimum value with which I can kill the monster. That's all. Uh, this is what is binary search. You may see the recording to understand it better, and you can solve more problems related to binary search. Also, uh, I think we should create a group somewhere in WhatsApp or Discord, and so that I can coordinate better with you and send problems there as well. I will send you a spreadsheet as well, so that I will add problems there and you can solve them as well. If you want, you can solve on your own, but of course I will add good problems, or at least I will try to. So anyways, this is the whole solution for this problem. I have already solved it, so I do not want to submit it again. But probably my solution will be the same. Not sure. Okay, what we can create a group on WhatsApp. Okay, I will probably coordinate with Sir Safwan to make a WhatsApp group later on.
Yeah, I hear that. Later we will organize this. Don't worry.
Yes, thank you. So let's move to the next problem, and probably these problems were good, and I just wanted to cover what you already know, but in more detail. So now you know, like, what type of problems, like, even though the problem was quite strange in the beginning, but we were able to solve with by using a simple concept, which is just predict sum. And the difficulty of that problem was 1600, so it was not easy. And similarly for this one, this one was a classical one, you can say. Like, this is called binary search on answer. Many people already know it. But I have like told you the concept in more detail, so you can solve almost any problem using binary search now. I will add more problems in a spreadsheet, which I will share with you soon. And then you can solve more problems related to these concepts. This was just 1200, but anyways. Let us go to the next problem. This is an easy problem, but it is from an Olympiad. It is from the, you can say, International Girls Olympiad. But this is, I mean, EGOI problems are good, and some of them are easy. The first two are usually easy. You can try them as well. And they are like, they are good as well, but they are not that close to IOI. So you can still try on them to get a taste of OI problems, Olympiad style problems, but they are not really like, you will not uh, be spoiling anything if you solve this. So you can just solve EGOI problems. So let me just explain the problem to you. This is our first Olympiad style problem. So what we have is just this. We have some n dishes, and their prices are given to us. P1, 2, 3. And what we have is Q queries or Q days. They say these are days, but to simplify or to put it in simple terms, these are just queries. What happens in each query is just this. One thing which can happen is this, plus X. This means everything, or like all the prices have been added by X. So everything increases by X. So if the array was something like 1, 2, 3, 1, 4, or 2, 4, and something like this happens, like plus 2, then everything becomes 3, 5, 5, 3, 4, 6. And what is the second thing which can happen? The second thing which can happen is set xy. This means
Sorry for the interrupt, but we can see only the code editor, not the board. The
sorry.
screen is still on.
Yes, I completely forgot to change the board. Thank you very much for informing me.
Okay, thanks. Okay.
So let me actually repeat the problem from the beginning. We have n dishes and we are given their prices as well. And now we have some Q queries. What happens in each query is just this. Either they tell us to perform this operation, which is plus x. Plus x means add x in every element of the array. So if this is the array 1, 2, 3, 1, 2, 4, the new array will be 3, 5, 5. Oh, sorry. Like if it is plus 2, then this will become 3, 4, 5, 3, 4, 6. So either this can happen or the other operation is set xy, which means every dish with price x gets its price set to y. So if it is like set 2 on y, let's add on as well because otherwise it might be confusing. So let's say set 2, yes, set 2 on 1. That means after this operation, the array will change to 2, 2, 3, 2, 2, 4. All the ones will change into 2. This is what is happening in summary. So you understand the problem, right? This is all you are given, and what you need to answer is after every such operation, you just need to say what is the sum of all of the values, like what is the sum of the prices. So let us just see some test case so that you can understand it better. So if these are the initial prices and the first operation happens, which is just plus 1, the first query is just plus 1. So we add 1 in every element, 3, 2, 2, 3, 6. And what is the sum now? The sum is just 3, 3, 6, 6 and 4, 10, 16. So you will just answer 16 after performing this operation. After the second query is set 3, 2, 3, actually 2 becomes 3, something like this. So 2 will become 3, 3, 3. Yes. So this is what is happening. And of course, you need to answer the, wait, sorry, I think I did something wrong. So set 3 to means, set 3 to meant actually that change 3 to 2. Yes. So instead of changing 2 to 3, we will change 3 to 2. So now the sum is just 8 plus 6 is 14. So you will just keep answering these queries and you have to update these values, so on. So how will you solve this problem? If you have any ideas, just send a private message. Basically, I forgot to say the constraints as well, but actually this is Olympiad problem, so the constraints are like there are subtasks in it. So of course the general constraints are very high, which are n up to 3 into 10 power 5. Like you just have to do it in O of n or O of n log n. Q is up to 10 to the 5 and Pi is up to 10 to the 6. But you can also, because a major part of Olympiad problems, I mean, a major difference between code forces and the Olympiad problems is, of course, the subtask. So you should, and these are actually very helpful as well. I mean, you should think, well, what I would say is you should think generally for a few minutes. But if you cannot have some observations or any ideas in the first, let's say, 10 to 15 minutes, then you can start thinking on the subtask because they actually help you to understand the problem better and like you're also making progress and you can just tick them off and just feel comfortable that at least you can get these many points. So uh, and then maybe you will, while making the solution for those subtasks, you might make an observation which can help to solve the full problem. So for the first subtask is just n is equal to 1, which is very easy, of course. It has a score of 14. You can see all of the subtasks from there. The second one is actually just brute force. I mean, you can just do brute force and that also gives you 28 points. The third one is actually, there are only type 1 operations. That means you will only do plus x in the whole array. And the fourth one is there are only type 2 operations. So that means only there will be no any operation of plus x. There will be no such operation. And the points for these two are actually good too. And to solve the whole problem is just 16 points. Of course, so you will, if you will do brute force, you will get 42 points. But of course, this is an easy problem, so most of the people will be getting 100 points here. You can send the solution of subtasks as well if you want to. I mean, I do not have any preference. If you want to send the full solution, you can send that to that, or if you are thinking on subtasks one by one, you can send that as well. And you can even send me ideas. I mean, even if the solution is not complete, you can maybe even ask if this direction is correct, if this thinking or observation or anything, you can just ask. Doesn't really matter. Yeah, I mean, you can just start thinking. If you want to think on the next month, you can just think the next month, because these are all too easy. I mean, you just have to do a for loop and just update using the set operation, or you can just do a for loop for plus x as well. So it is quite easy. So the first operation is just not, I think maybe I think I explained it correctly, but some of you are taking it as +1, I think, but it is plus x. So they will give us x, and x will be added in every element. So you have to print the answer after every query, not just after all of the queries. let me actually tell you the solution. So of course, let's go subtask by subtask. This is just brute force. You can just do a loop in every query. And for this one, you can just maintain one variable, which is sum. So when we use sum, of course, when we are adding plus x in every element, what is happening is just the sum is added by n times x, right? Because in each element, x has been added. So overall, the sum is increased by n times x. So this will be all. I mean, there is no other operation, so we can just keep doing this. And what happens when there are like just set operations? When there are just set operations, we can just keep track of like the frequency of each element. So if some element x is changing to some element y, then what is actually happening? Like what is the change on the sum? That is all we care about, right? So all x's change into y, right? So let's say we have count of x and count of y. So if one x changes to y, what happens? The sum increases by y minus x. So if there are count of x occurrences of x, then the sum will just increase by this. I mean, this is very similar to that. And this is just math. So the sum will just increase by this, and we can just say count of x becomes 0 because there are no x's remaining now. But before doing this, we actually have to say count of y plus equal to count of x, because now all of those x's have actually become y. Although this is a very simple problem, but the Olympiad problems, I mean, this is the easiest problem of the contest, but still it can lead to, for example, some bugs, or like the implementation is not always easier, and the problem statement is also a bit hard to understand. This was relatively, I mean, smaller problem statement, but other Olympiad problems usually have very long statements. Usually IOI problems in both years in which I have participated, they were very long, and sometimes you can maybe misread them as well. So anyways, so we can just solve this subtask using a map. And in this one, we have to combine both ideas, but we also face an issue. Why can we use the map here, but why cannot we use, I mean, what if we just combine both of these solutions, the map solution and the sum solution? So if you just say if the query is of type 1, if q is 1, whatever. So just do this sum plus equal to n times x. Otherwise, I mean, write this. So what happens is, I mean, the thing which is destroying preventing the accepted from getting this solution accepted is just this. Like, actually, this is changing the prices as well, but we are not updating them. And when we come here, it gives us x and y, which are actually the updated values. I mean, it says set all x's to y, but we also have added plus x in all of the elements in these queries. So like if we have done these queries, then these queries are after that, so they can have some effect on us. I mean, you probably understand, but let me explain it anyway. So if this was the array, then right now changing 2 to 3 means changing these 2's to 3. right? But if we add +1 in every element, like a +1 query first comes, then this array will become 6, 3, 3, 2, 3, 4. Yes, 4 and 8. So now if 2, 3 comes, it will not mean change these 2's to 3. It will mean change this 2 to 3. So that is why our previous solution, if we just copy and paste our previous subtask solution, it will not work. Obviously, I mean, it cannot be that easy. So what can you do here? I mean, some of you have already made the solution and it's almost time as well. And so I can just explain it now. So what is actually happening is every time we do this operation, all of the values shift by the same value. This is like a very good thing which is happening here. So we can use this, you can say, I mean, they are kind of helping us. If they had something like add in this range, then it would be a hard problem. But for now, since every element is changing, we can just say if we had to get from the new element the actual array element, what will it be? It will just be the shift, like what it is shifted by. We can just subtract that shift, right? All of those operations of inflation or the type 1, if we just subtract them, we will get the original element. Yes. So we can just keep track of this shift, right? But there is still a problem. I mean, now that we can get what is like, if they are saying change 2 to 3, in our map, it will be like change 2 minus shift. Let's say, I mean, actually 2 minus 1 because our shift is right now 1 to 3 minus 2, 3 minus 1. So it will be like change 1 to 2. So we will change this 1 to 2. Yes. But we will not change it to 2 actually. So as per 8, will we change it to 2? No, we will not. Yes, we will not change it to 2 because what we are saying is this shift is happening for everyone, right? So if we are changing this element into this element, if we just change it, then that will mean, no, wait, we will actually change it to 2 because we are still keeping track of the shift. I was just thinking that if we change it to directly into this, we might lose track of the shift, but if we change it to 2, then it will be correct. Yes. So we have to actually do this. That is what I was thinking. Yes. So we will just say instead of changing 2 to 3, we will just change 1 to 2. And that will mean we are still thinking of it like what is like the shift will stay consistent. That is what I mean from this explanation. Hopefully you understand, but if you want me to explain again, I can explain it better, I think. Like we need to make sure even after setting that the difference between the actual value right now and the initial value stays shift, because that is our definition of shift. Because every time we assess something in the frequency, we want to assess the initial thing, and so we will subtract the shift. That is why when we are changing, we want to change in such a way that it will still satisfy. I mean, if we want to assess the initial element, we will assess the initial one, not the updated one, like not 3. We will try to assess 2. So I think you understand. If you have any questions, just let me know. Otherwise, it's good that you understand. I will, of course, add all of these problems in the spreadsheet as well, and I will add more problems of each topic we keep, I mean, we discuss in the session. Can you show us the code? So I have actually implemented this sometime, but not sure on which website I implemented it. But it will, let me actually implement it right now then. There are, of course, no test cases in the VR. Wait, are there? Maybe where? Let me check. Yes, there are no test cases. So what do we keep? What do we need to keep track of? Let me actually read the input as well then, since we are implementing it anyway. And then we have the prices and then the queries. So when we get the prices, what we can do is, what are the three things we are keeping track of? It is the map, which says count, and or you can say frequency if you want to. And there is a variable sum, which is the answer for every query. It will be 0, of course. And there is shift. Like, what is the shift on each element? Yes. So when you read the input, of course, you can just save everything into the map instead of an array. So you just do this. Next, frequency of x increases by 1 and sum increases by x. Of course, there is no shift right now. Then you read q, c in q. Yes, and type, let's just say t, c in t. If t is relation, then this is the type 1 query, otherwise it is the type 2 query. So if it is the type 1 query, what do we need to change? I mean, all we care about is these three variables, right? So of course, sum increases by n times x. So we will just do that. Oh wait, I haven't read x. Seen x. I usually just write integer everywhere. Sometimes I get a wrong answer after that, but I mean, I just submit with integer. But I usually do this to change everything to long. Anyways, that is why I'm doing integer right now. But of course, the sum can exceed 10 power 9 easily, or 2 power 32. So what is happening is when an inflation comes, what can we do is we can add the sum and the shift will increase by x as well, right? And then what can we do in the set? We will have, of course, x and y, seen x and y. And what did we say on the notepad? Since when we are changing 2 to 3, we will change 2 minus 1 to 3 minus 1, right? So we will change, we will change x minus shift to y minus shift. So we can just subtract them by shift. This will be their actual values in the map, right? Because all we care about is their initial values, because we are not updating the values in the map when we do this. So now we can just change. So of course, the sum increases by, as we said in the second last subtask, by frequency of x times y minus x, right? And what else changes? Frequency of x, of course, becomes 0, but we, of course, need to do this after we update the frequency of y. Sorry. Yes. I think this is it. Should I submit? I'm afraid of getting a wrong answer. So shift is for, like, it is to keep track of all of these operations, because in the map we are not changing the values, right? When this operation this operation is changing everything. Yes, your solution is yes, very similar to mine. Okay, so shift is just for this. You mean how? What do you mean how? I mean, so shift is just keeping track of what is the what are the current values according to their opinion. That is like initial values plus shift for every value. But for our opinion, I mean, we just want to keep everything equal to the initial values, because we don't want to update for every value in the array. We do not want to update the frequency every time this happens, because every one is, if there are some ones, twos, threes, then if plus 3 happens, then we do not want to change frequency of 1 to frequency of 4. I mean, this will take often time, right? So that is why we do not want to do it. And how are we using this shift to solve this issue? It's just using this. I mean, let me share the whiteboard again. Yes, it is the sum of the inflation values, not the times it happened, but if some plus 2 happened here, plus 3 happened here, that means the total inflation is 5. This is our shift. And it just means, like, let's say if this was 1, this means at the end this value is 6. When they will give us the query, the set query that change 6 to something, they will mean this 6, not the initial 6. So that is why we want to use this shift thing, so that we can assess the actual element in our map. I mean, they will say change 6, but we will actually change 1, because that is how we have saved it. And of course, we cannot save it like 6, because that will take too much time in every inflation move, in every inflation type query. So do you understand the idea now? This was, I mean, a bit harder still for you guys. I'm impressed that you guys, some of you solved it. So that is really good. I think I will just add some hard problems as well for those who are, I mean, who are really able to solve these hard problems. That's great. Okay. So yes, I think this will be it. I will create a WhatsApp group and I will share the link with Sir Safwan. And do you guys also use Discord? Because it is the same thing, but I think probably you use WhatsApp, so we will create a WhatsApp group. So this is it. If you have any questions or comments or feedback as well, I mean, if you want to solve, if you want to solve, if you want me to uh, uh, like get more Olympiad problems in the sessions, so that we can solve more Olympiad problems, you can say that as well. Or if you think that we should focus on concepts which can appear. I mean, of course, I will absolutely cover all of the concepts which are required to get a medal, but if you want, we can increase the pace further. In this session, we solved 4 problems in around 2 hours. We started a bit late, and so I think this is actually faster than. But anyways, I mean, it should be fast for you guys. You guys have so less time and so many things to do. Also, I heard that your team selection test is